All right, so factoring is just rewriting an expression as the product of its factors. So again, it's going to look something like this, where we have that P and Q, and P and Q are just numbers. Okay. Now, to kind of give you a little bit even more of a basic idea, so if we're taking something and writing it as a product of its factors, so let's say we had 8. I can get 8 by taking 2 times 4. Okay. So this would be the same idea as our expression, and then these would be the factors. So we're just taking a quadratic equation in standard form and rewriting it as it's the 2 factors that we would multiply together to get that again. Okay. So to start with, we're going to talk about our GCF, which is our greatest common factor. And these are going to be a common factor in all of the terms. So this is something that we can divide out of every single term in our expression. Okay. So if we take a look at problem 1, we want to figure out what we are able to divide out of every single term. So if I'm looking at this between 4, 20, and 12, I can divide 4 out of all of those. And then I would want to look to see if I can factor out a variable. So the first term has 2 x's, the second one has 1x, but the third one doesn't have any. So I'm not able to take an x out. So the only thing that I can factor out of all 3 of these terms is 4. So when we factor out, it's the same idea as dividing. So we're going to go through and divide each one of these terms by 4. So 4 divided by 4 is 1, so we're left with x squared. 20 divided by 4 is 5. And then the x just stays there. And negative 12 divided by 4 is negative 3. So that's going to be my factored form, so I can't do anything else with it right now. So if we look at the next one, again, we're going to start with the numbers. So what's the highest number other than 1 that we can divide out? And remember, when we're factoring, the first term always has to be positive. Okay? So between 9 and 24, we should be able to factor out a 3. And then since our first term is negative, that means that we also want to factor out the negative to that. And then we look at our variables. So does each term have a variable, the same variable in it? So here we have an x and an x. So the highest amount of x's that I can take out is going to be 1x. So now we're going to divide the numbers. So negative 9 divided by negative 3 is positive 3. And then we're subtracting the powers. So x squared and divided by x. So I'm going to take 1x away. That means I would have 1x left. Then we go to our next term and do the same thing. So negative 24 divided by negative 3 is going to be a positive 8. And then I'm also dividing out an x. So if I only have one x and I take it away, I won't have any left. So our last term won't have an x in it. So that would be our factored form. And again, the way to check to see if you factored correctly, if you multiply this back together, you should end up with your starting answer. All right, our next one. So again, looking at our numbers, between 4 and 12, I can take out a 4 from both terms. And then it looks like I'm able to take an x away. Oops. So 4, and then we can take an x away. And then I'm also able to take a y out. So now 4 divided by 4 is 1, so I'm not going to write it. I'm taking away one of the x's, so I will have 1x left. And then I'm also taking away the y, so I won't have any of those left. And then plus 12 divided by 4 is 3. I'm taking away the x, so I'm not going to write it. And then I'm taking away one of the y's, so I'm still going to have 1 left. So this would be our factored form for that problem.